Computers are like musical instruments, built to perform. They're machines, cleverly crafted, but made of dumb stuff. They can do only precisely what they're told. What makes them perform is a stream of instructions, written in code. The code of composers is called musical notation. The code of computer programmers is software.
It didn't occur to me at the time that I just had to program in order to be a happy man. You know, adding a couple of lines to my program give me a real high. It must be the way poets feel when they're or musicians and so on.
Don Knuth has spent 5 decades of his life practicing and teaching the art of programming, a discipline he loves.
I saw my first computer in 1957, which is pretty late in the history game as far as computers are concerned. On the other hand, programming was still pretty much a new thing. One night, a guy showed me how it worked, and it was love at first sight. I could sit all night with that machine and play with it.
To people who loved puzzle solving and intricacy, early computers were seductive and empowering. Astonishingly fast, they seemed capable of figuring out just about anything. Anything, that is, that could be expressed using the native commands for that particular computer. It's machine language.
Computers are very, very dumb, and you have to use very small words to make them understand, and you have to speak in a very formalized way a lot of times. That's what programming is knowing how to speak to the machine in a way that will make it do the little dance you want it to do.
Early programmers wrote machine language in numbers, numbers representing strings of zeros and ones, on and off. The binary commands an individual computer circuit can understand. But for humans, writing in numbers is tedious and error-prone. So it didn't take long for programmers to invent ways of making this machine language more human-friendly. The first step was to substitute names and symbols that were easier to remember, and then get the computer itself to translate this coded assembly language into binary. Assembly language was still tedious, but using the computers themselves to translate from human programming languages to the machine's binary language was the key that unlocked the software revolution.
Well, programming, in machine code was pretty lousy business to engage in. I mean, all that was available was in a sort of a very crude assembly program. And so I figured, well, let's make it a little easier.
After 4 years' work in 1957, IBM released the first complete higher-level language, Fortran. Programmers could now express familiar scientific formulas and logical instructions in statements that made sense to them. Fortran compiler software would then translate these formulations into the expanded instructions in binary the computer needed. Programmers no longer had to learn each computer's machine language instructions. Instead, compilers were written to translate Fortran programs for any computer. Fortran was written for the scientists and engineers who first needed and supported computing. In 1959, a language called COBOL made programming for business applications easier. Based on experience from Grace Hopper's pioneer Flowmatic language, COBOL, with its close-to-English expressions, became the most widely used language for creating business software. Over the decades, hundreds of languages have been written, optimized for different needs. The expressions in these languages became more distant over the years from what the machines would need to do. Let's say, add the next data item to the running sum, and closer to what the programmers really wanted to achieve. Like, create a list of expensive books sorted by title. As computing became personal, so did programming languages. Today, millions of us do, routinely, what programmers do. We tell a computer in code what we want it to do. Like, compute the average of all our salaries.
We invent languages that let us simulate other languages so that we can allow people who are experts in businesses do their own programming. And one of our goals in the 70s, which I think has happened, is that most people feel empowered to change the computer.
Writing standardized, compact instructions is just one part of programming. Software programs exist to process data, all kinds of it. Data also needs to be interpreted and organized for binary computers. Of course, binary numbers can represent the decimal numbers. Some have been assigned standard interpretations as alphabet letters and symbols. Data gets organized into strings, into lists, tables, trees, and more. Defining how data is represented and organized has become more and more important. After all, stupendous quantities of data are now accessible to the world's computers.
If I had a video camera, several of them around me, from the moment I was born until the day I died, I could probably keep all that information easily in today's technology in about the space of a sugar cube. So the question for me from the software side is what can I do with that?
What the programmer wants to do is get answers and solve problems. Choose an appropriate language. Define how the data will be represented and structured. Now the programmer must create step-by-step procedures that will accomplish the task, much like a chef creating a recipe. The programmer's recipes are called algorithms.
Which doesn't mean saying, now computer, you do this. It means thinking of a series of operations and a way of specifying those operations that will make the events occur that you want to occur. And that sounds so simple.
It's almost never really simple. For even the simplest steps, like sorting data lists in order, there are hundreds of possible algorithms. Good, there are thousands of kinds of problems. How do you look up a customer in a list? Doesn't seem very hard. Find the best route from A to B? Not so easy. Model the forces in a hurricane? Very, very complicated. Easy or hard, all programming problems are solved with languages, data structures, and algorithms. Plus, a lot of hard, focused concentration.
I found that writing software was much more difficult than anything else I had done in my life. I had to keep so many things in my head at once. I couldn't just put them down and start something else.
Programmers write software in a world of technology that's constantly improving. Their efforts have always pushed computing toward more complex, grander achievements. It seems that will always be true. Writing new software is an act of human creativity. It is the highest of high tech, and also an art.
You know, I just want to, I want it to be elegant in a way that, that hangs together, somebody can read it and smile.
Software programmers have extended our reach, amplified our minds, and given us immense powers in a world alive with information and interaction. Those who lived not long before us would have called it magical. But it's not magic. It's software, making computers work.